Welcome physics students, this is Mr. Conti, and we'll be going through the graphs from Unit 3 Stacks of Kinematic Curves worksheet. Let's take a look at number 1. This is from our last unit. This describes the motion of an object who begins its motion at the origin, moves in a positive direction with a constant speed. That's because the graph itself begins at the origin, moves up in a positive direction, and then also has, because the shape is a line, it has one slope. That means it has one speed. So to describe the velocity, we look at the slope of the line. It's positive and constant. So let's pick a positive number, positive position for the velocity, and show that it's constant. So it should be a horizontal line where the velocity doesn't change over time. Our new graph, the acceleration time graph, is a description of the slope of the velocity time graph. So if we go back to the velocity time graph that we just drew, the slope of that line is 0, because if there is no change in velocity, then there is no acceleration. So we'll label the acceleration as being 0 over time. In graph number 2, the object begins some positive position away from the origin and moves in a negative direction towards the origin with a constant speed. Again, looking at the slope, we can say that the velocity is both negative and constant. So we're going to now pick a negative velocity and show that it is constant throughout the entire time. The slope of that line is still 0 because with constant velocity, doesn't matter which way you move, if there's no change in the velocity, then the acceleration is 0. But now 3, we get a different shape. We're dealing with a curve here, so that implies that the slope is changing of the graph, and so the velocity must be changing. So there will be an acceleration for this graph. Now, similarly, if we look at where the graph begins, this tells us where the object starts its motion, and that is at the origin. The graph goes up, so it's moving forward. But because the curve is getting steeper as it goes along, that implies that the velocity is increasing. So if we take a look at the tangent lines, and I'll use the blue color to indicate the tangent lines. The tangent lines start off flat and begin to get steeper as it goes up the curve. So that indicates that the speed is increasing. From 0, we'll assume that the object starts at rest, so we find v equals 0 at time 0 and show a constantly increasing speed in the positive direction. Now, describing the slope of this graph is similar to describing the position time graph of number 1. The slope is positive and constant, so now this describes the acceleration this time around. The acceleration now is positive and constant. So because the velocity begins at 0, having a positive acceleration means that the object will pick up speed in the positive direction over time. Let's take a look at number 4. This object begins its motion some positive position away from the origin. It moves back towards the origin in a negative direction. And what about its speed? Well, we take a look at the tangent lines again, and you can see that the curve begins flat and gets steeper, but also more negative. So this means that the object picks up speed, but in the negative direction. So we're going to still start our velocity time graph at 0, but the values of the velocity will get bigger, but more negative. So this is increasing in the negative direction. The slope of that line is negative and constant, so that implies that the acceleration is negative and doesn't change throughout that time. So what does this mean? So if the object begins with no speed, it begins at rest, having a negative acceleration means that it's going to pick up speed, but in a negative direction. Let's take a look at number 5. Number 5, the object begins its motion at the origin, moves forward, but what's happening to the speed now? Well, if you look at the tangent lines again, they start out steep this time around and get less steep as we go along. So this is an object that's slowing down. But this first tangent line that I drew is steep but also positive. So this is a positive velocity that it has. So we have to pick a positive velocity and show that it's decreasing with time. So the values of the velocity are decreasing. So it looks like that. And the slope, describing the slope of this graph is similar to describing the slope of the velocity time graph in number 4. It's negative and constant. So the acceleration is negative and constant. The difference here is the object has a positive velocity to start with. So if it has a negative acceleration, this takes away from the positive velocity that it has, and so that means it's going to slow down. And so those are the first 5 graphs from Unit 3's stack of kinematic curves.